All right, guys, we're starting the last section of Chapter 3 today, which is measures of relative standing. Take us a couple of days to get through it, but that's okay. Today we're going to look at mainly one of those measures. And what the measures of standing do, it tells you, they give you numbers that show the location of data values compared to or relative to other values in the same data set. So if you get a whole data set and you take a value, you can use some of these statistics to tell how they're located in relation to the other ones. So that's what we're doing today. What we're using today is the most important one. It's called a z-score. Z-score is also called sometimes a standardized value because it works with the standard normal distribution normal curve. So that's kind of what gets its name. It involves converting a value to a standardized scale. So we're going to take the numbers that we already have, convert them to a standardized scale using a z-score. What it does, this is the most important thing about z-scores. You need to know what they are. What they tell you is how many standard deviations away a data value is away from the mean. So how far is a data value away from the mean? That's what the z-score is going to tell you. Whether it's 2 standard deviations, 1, 1.5, it doesn't matter. And the last thing here is we're going to use z-scores a lot. I mean, a lot as we go through the rest of the year. So something you really need to know. Took this picture straight out of your book. It says, tells you what it is again. The number of standard deviations a given value x is above or below the mean. And there's the formula for it. Now, these formulas are really the same, just one's for sample and one's for population. What you do is you take the data value they give you, subtract the mean, divided by standard deviation. Population the same way, just the Greek letters are different because it's population. Data value minus the mean over the standard deviation. And also, we're going to always round z-scores to 2 decimal places, and because we're going to be using a table with them later, and the table has 2 decimal places in it, so that's what we have to do. All right. This one says, last week we used the CV. Remember, CV is the coefficient of variation to compare the variation among numbers of chocolate chips in the cookies to the variation among weights of regular Coke in cans. And we had to use CV because they have different means, they have different units, pounds versus chips, so we had to use CV. Now, consider the 2 individual data values, keyword individual, with this question: which of the following data values is more extreme? Okay, here we go. The Chips Ahoy cookie with 30 chocolate chips, or the can of regular Coke that weighs that much. Now here's how we can tell. We can do the z-score to tell us how far away each one is from their mean. So I'm going to do the blue one first. The Chips Ahoy, I'll change to blue. You take the data value they give you, which is 30. You subtract the mean, and you divide it by the standard deviation, which is 2.6, to get your z-score. And when you punch all that in, you get a z-score of 2.31. When you do the other z-score for the Coke, the green color, the green cans, you take the unit they gave you, which is 0.8295. You subtract out the mean, which was 0.81682, divided by the standard deviation, which is 0.00751. Punch all that in, and you get 1.69. So here's the deal. The Chips Ahoy cookie with 30 chocolate chips is that far away from the mean, its mean, 2.3 standard deviations, 2.31 standard deviations. The Coke can is only 1.69 standard deviations away, which means the Chips Ahoy cookie is more extreme than the can of Coke. That one's the more extreme because it's further away from the mean, more standard deviations away. So we can tell this way now instead of having to use the CV with different data sets. You can use these scores like we did last week to find unusual values. Remember what we used last week? We said if it was within 95%, well, it was 2 standard deviations away last week. Remember we did 68, 95, 99.7 with the empirical rule? Well, z-scores give you how many standard deviations away. So usual values, or 95% of the values, should fall within -2 and +2 standard deviations. So if you get a z-score that's less than -2 or bigger than +2, then that's considered an unusual value. And I got a little picture here. I took this one out of your book also. It shows the unusual values less than -2, anything over here, and the unusual values greater than 2. The ordinary values, or the usual values, will always be between -2 and 2. And that should be right around 95%. It's not exactly 95%, but it's pretty darn close. Okay, let's look at this one then. It says a man's pulse rate is measured to be 48 beats per minute. Is this pulse rate unusual based on the large amount of pulse rates that showed a mean of 67.3 beats per minute and a standard deviation of 10.3 beats per minute? So the only way to tell that is to find a z-score and see where it falls. So I'm going to find my z-score here. You take the data value, the 48, you subtract the mean, 67.3, which tells me it's going to be a negative z-score. Standard deviation is 10.3. Punch that in your calculator. See what you get, and I get this. I get negative 1.87. So 48 beats per minute, that's really pretty low, but because it's still within -2 and +2, we would say that that is ordinary, or it's not unusual, because it does fit in there. It is within a 95% range there, so we would say it is ordinary or usual. Okay, 4 properties here before video ends. First property is z-score. Don't forget what it is. It's the number of standard deviations. The given value is above or below the mean. That's what the z-score tells you, how many standard deviations away you are. Number 2, they're expressed as numbers with no units of measure. You can't say, well, the z-score is 10 inches or 2 inches. There's no unit of measure. It's just the z-score. Number 3, a data value is unusual if it is less than -2 or greater than +2, if the z-score falls over there. And number 4, if an individual data value is less than the mean, the z-score is a negative number. You can have negative z-scores, and that's fine. That just means if you're thinking about your normal curve, it's to the left of the mean instead of to the right. And one last little thing down here, I barely can read it. A z-score is a measure of position. It describes a location of the value relative to the mean. It tells you how far away from the mean it is. That's where the z-score is. I've tried to drill that in your head during this video. I've said that 100 times. So hopefully you picked that up. We'll work on z-scores tomorrow and doing some problems with them. Hopefully you find it very easy. I think it is. But it's worth a day, though, because we're going to be using them so much as we go on. Need to know what they are and how to calculate them. So see you tomorrow.